Hello all. Welcome you all for this session. We have a speech on Python in science it's going to be given by Mr. Igor. He is a doctoral student at the Department of Physics, Chemistry, and Biology, Theoretical Physics at Linköping University, from Linköping. He was developing web application using Python, and so I think he is the right guy for talking about the science using Python. So I hope we'll have a nice session. Thank you.
Okay, so
And I have the mic with myself, and if you have any questions, you can ask me.
hello everyone. I was actually expecting to see less people. I'm kindly flattered, so I'll be probably more nervous than I anticipated. But anyway, my talk is not going to be about data science because I think that data science is covered pretty much widely by Python. There have been a recent article in Wired, I think, that Python finally overstepped R in data science community. So that part is, I believe, covered. And for any scientist, the phrase data science sounds strange because for them, data is science. So they've been studying this all along. And if you look at the Python main page, you can see that it lists application that's it's scientific and numeric. And that was my one of my reasons to go for a PhD was that I was considering myself that I was relatively good in Python. I was doing some web development, and then I found that there is a field which sort of merges the skills that I had in Python and my interest for physics in general, that I thought that it might be interesting to go there and see what sort of interesting problems I can find there and maybe help other people to solve. And I was a bit disappointed, as I guess it's no surprise to me looking back. But the thing is that I always thought of myself as a sort of a sheep in a wolf's coat, that I'm not really a physicist on one hand, that I'm a programmer inside, and on the other hand, I'm not really that much of a programmer, but some sort of physicist, so some sort of a quantum particle, I would say. So I'm doing a lot of what can be titled as computational material science, which is a relatively young field on one hand. It's been a reasonably low number of years since a major breakthrough came in, like maybe 20, 25, that actually allowed people to solve a lot of huge problems on a supercomputers in a parallelizable manner. And if you go to fundamental laws of quantum mechanics, the problems that you can tackle are still relatively small. It's like maybe 200 of atoms. If you add temperature to that, then that's a reasonable assumption what you can model and what properties you can get of a system in a reasonable time frame, like saying that your simulation will run for a couple of months. So because of the maturity of the field, there's a lot of black boxes, like the tools that you can get someone from other field, like an experimentator. That last week I was just teaching some guy from the friendly lab that wanted to see some properties of the material, and he was an experimentator. And in this field, it's quite easy to distinguish between experimentator and a theoretician, because experimentators has Windows on their laptops, and all the theoreticians, or the guys who think of themselves as a theoretician, tend to use Linux or Mac OS. And because of the maturity of the field, there's still relatively low barrier of entry, because you can sort of say to some guy like, okay, take this input file, just change this, and this will work. And this will give them quite far, get them quite far, up to a point when they will have like a calculation that will require a few thousand of files to be submitted and to be edited. And I even know a few guys who did it by hand, just copying the folder from this some sort of a FTP-looking client from Windows, just copying, changing one line in the file, then copying again, and doing it for like 1,200 times, and getting results, which is amazing. How much time resources he have. And the people in this field tend to think of themselves as a relatively smart people because they figured out quantum mechanics. So they don't really enjoy doing programming. That's one of the problems here. So for them, it's much easier to run this, to do this monkey business with moving files and changing only one line in the input, than just like sitting down, spending half of a day playing with bash scripting and just doing the same thing in one go and just replacing some parts of it for the second run instead of repeating it, which is for some reason doesn't occur to their heads that it can't be done easily, that it's not that rocket science in that sense. The other thing that is relevant to any field of science, I would say, there's this publish or perish attitude that people who tend to work in science need to publish stuff, otherwise they don't get grants, they don't get money, they don't get new PhD students, and the cycle will break. And that means that most of your research there needs to be non-interactive, needs to be publishable. So when you look for most of the tools that are currently trending in Python, these are like this Jupyter notebook that allows you to do some interactive fiddling with data. There are some tools that help you do interactive plots out of the box, like Boken. And unfortunately, they all are not applicable for this type of work. Usually you have to step down your fidgeting and just do the bare minimum stuff to get it published. And for that, unfortunately, the tools that we have are not really that useful, but I'll come back to it a bit later. The thing with being really smart and clever is the thing that follows, that a little bit of arrogance, which is quite familiar to anyone who's working in IT, I would say. And it turned out this is an SVN subversion log of a really clever project of some guy. This project is being used by other people, but it's impossible to maintain and read if you're not that guy. Like if you stroll down a little bit, you see that there are some Swedish comments, and the most meaningful one is like 100 lines, 100 revisions behind. That's something we do with iFortran. For this type of applications, because the field is mature, it's a little bit more mature in computational time scale than the origin of Python. And most of the tools there are based on C and Fortran, which is fine. Actually, I found out that Fortran is not that bad of a language if you take the later versions of it. It's especially good for a physicist because at some point there was a competition between different suppliers of compilers for Fortran, which sparked the idea that if your code is written in a crappy way, but it compiles to a fast code, then it's a good compiler, which inevitably leads to a really unreadable code. In my case, with a lot of Swedish comments in it. But it took a while for this guy to actually publish his work, to say to other people that, okay, I have now this stuff in repository. And then there was like a year when he was giving this code to other people. Other people were like, okay, I'll read it. I'll see what I can do with it. And then never showing up again in his mail list and never communicating with him because the code wasn't readable. And it took maybe 9 months for him to realize that it's actually his problem because he's not providing enough documentation to it. And maybe 3 more months to actually write it up like this. Please use these settings, install this part on your supercomputer setup, and so on. And for a scientific workflow, you can clearly distinguish these 3 parts. That you prepare the input files. I'm talking again about my field. Probably there are some other cases, but you prepare a lot of input files. Then you submit your calculations to a supercomputer, and then you wait. Typically, first you wait until it gets to a queue, and then you gets propagated in a queue. Then you wait until it's finished. Then you probably realize that you set up something wrong. You need to rerun it again, and so on. So it's natural. And then you need to process results. So Python clearly comes in the first and the third part because this one is dominated by those black boxes, which have been written in Fortran, which are good, and which I don't believe will ever be overseen by Python in any case. And the first part is clearly better solved by Linux internal tools like bash scripting. On one hand. On the other hand, for those who has Windows on their machines, it's still quite a challenge to make it work. And for them, sometimes it's easier to do a Python part. I remember when I started my PhD, my first goal was to write some sort of a small setup script that would help just write these unreadable, in my opinion, input files for one of the black boxes that we use. And no one was using it because it was written in Python. And even after I converted some parts of it to shell scripts, it was kind of unusable for other people, which is sad, but I guess for some people it's easier to just copy-paste a lot of files. So again, we see that most of the part working with Python in science goes with processing results, and as I said, the trending stuff is interactive plots, which are not really used that well. And those tools that are useful, they are not really that friendly. Here is an example of a new plot, which is a plotting program written by 2 physicists that at some point, I think it's 15 years old, or it started 15 years old, but it's been developed. And if you look at it, you don't need to know any syntax details to actually figure out what is done. The main part here happens around line 11 and 12, where it actually set up some function, and then it feeds the data file through that function. And as a physicist who doesn't know any computer language or basic bash scripting is enough, for them, it's just a question of figuring out what's the actual arithmetic for entering the expressions, like how I enter the power sign, what's the word for exponent, does it need to be uppercase or lowercase. And that's a tool which I use to do basically half of my work. In a similar way, I ended up writing my Python scripts that would actually generate this type of input to that program, because that would be easier for later to tackle, and that would be easier to maintain than the stuff that I was getting when I was Googling for how to I fit a function using pure Python. And that's the example which you find on a Google search. If you just go for, okay, I want to find how to actually do that in Python in a pure way, you get to a SciPy documentation page, which has a lot of weird stuff like Lambda, which is a really strange word for a non-programmer. I mean, for Python programmer, all this stuff makes sense. You don't even like think about it as something strange. But for a non-programmer, and I'm omitting here the parts where you actually set up the input files, because that's also like a lot of lines that doesn't make sense when you create some additional points there. And that part was stopping me from adopting the usage of Python overall in my scripts for maybe 2 years. Then Jupyter Notebook came, and I realized that it's quite fun. But again, it's much more complicated than just like writing 2 lines of just, this is my function, I want to feed it, and I want to plot it. Maybe I'm already too old for this stuff. I'm not sure. Maybe I love this nuplot too much. But for me, this is much more complicated. And for most of the Python tools, unless they're developed for data scientists, for whom it's not really a problem, because they already know the Python, they already know the necessary magic that has to go with it, this is probably not an issue. Therefore, it's not get developed, because data science is trendy, and other type of science is not that trendy in Python, I would say. And so what you can do about it? I think that I personally know a few friends who are programmers as their main occupation, but they had some sort of physical backgrounds. And one of the reasons I went for my PhD was that I had this sort of a guilt from the university that I was shown a lot of nice physics, but I'm not probably going to use it because I was planning to go to be a programmer. So part of it tricked me into doing PhD in physics, which was probably not the best decision, but nevertheless I'm doing it. And you probably have a different type of friends who actually doing PhD but had some programming experience. Just try to reach out to them. I know this is a really strange message, but a lot of them don't realize that if there's something that you can automate, like copying these multiple files, then you probably it would save them a week worth of time, at least, or even more. And if you don't have such friends, it's good to go to local meetups or like game jams or something. In Linköping, there is a game jam community where a lot of physicists who go there, and I found a few friends that I was always seeing in the corridors that were there, and it was fun to see that they actually care about the similar things. And I think if we keep doing it, then the problem would be less severe. But I don't really see any other solution except for communication here. So if you want to contact me, there are my contacts. And by this, I end my short talk. So thank you very much for your patience.
Thank you. Anyone have any questions?
Do you see a change in attitude when it comes to the willingness to adopt Python, for example, to facilitate those things? I mean, is it an age gap thing, or is it really?
It's an age gap in a sense that if the person who I'm talking to is just got into the field, then he probably willing to try new things.
Okay.
So it doesn't really matter of his biological age. It's his novelty in the field what matters. And then it's really hard to, for those people, it's really hard to find out what's proper way for them, because most of the tools that I use in my work only recently been ported to Python 3, for example. So if you look for just which Python should I use, the main part of the articles you would read would say that you should use Python 3 because Python 2 is like the past. And then they end up using something like Python 3.2 because that was in their stock repository of their old Debian or something. And they get eventually they get to problem like they want to write a, I don't know, Unicode comment in their file, and they end up dying horribly. And I think right now it's mostly the case of time resources they have. So if they just start in the project, maybe if they have the right attitude to it, they will try to use Python. But if the case is like the supervisor is standing on top of them, like saying, you need to do this calculation, please start, and not try to spend like your weekends learning Python, then there's no hope around it, I would say.
Thanks.
But for most of, I heard a lot that NumPy is quite hard to understand for them. And a lot of people, at least 5, which is quite big number in this, told me that they tried to use NumPy, but they ended up writing the same thing in Fortran instead.
Just have a small question because I used to do the like mathematical simulations in it was in C++ and solid state, and we used many body quantum mechanics. So I just wonder, do anyone use quantum field theory nowadays? Because I kind of got the feeling that the computer wasn't strong enough 10 years ago.
I don't think that anyone uses it as I don't think that there's like a black box package that is capable of doing that.
Okay.
This is slightly different field than mine, so I'm not sure if that's the case. And I think that a lot of people who are doing that, a lot of people who are doing mathematics, there's no problem for them to study computer science and write good programs in badly syntaxes like C++ on templates and Fortran interfaces. And this is also the problem with most of those Fortran black boxes that don't really scale that well. For example, in Europe, there's Association for High Performance Computer that has grants for computer time. Like there's top 10 fastest systems in Europe, which you can apply for time. And then if your project is concise enough, then they will give you that time. And I think the biggest computer on that list is number 11 in top 500 list. And the PDC's Beskov supercomputer is number 51 in that 500 list. So in principle, it's worth going for that type of time allocation. But if you use that black box, it's not really scaling that well, and you don't really get that top-level systems. Maybe if you write your own software, I know that a lot of people doing quantum chromodynamics, they get that grants because their problems are embarrassingly parallel. And for them, it's easy to just get everything that they can.
Pretty cool.
Anyone else wants to share something?
So did I understand you correctly that the sort of the data transformation, usually the input files or whatever, is sort of the main problem? Sort of just they have, common problem is that they have some data they need to put into the system, so that they actually need data transformation from some given input.
Yeah, I mean, there are a lot of tools like point and click type of tools, where you can just have like one system where you can put atoms at specific positions, and then you can sort of shift the cell a little bit and then calculate that one. But that requires a lot of clicking, and it's not really you cannot make it in a batch, so to say. There are some tools that can be scripted, but they use Python again, and for them, typically that type of problems that they tackle are quite specific. And if they're just an experimentalist who has some nice result from his experiment, but it's not enough to publish, so he wants to have some calculations aside in his paper to make it more solid, then he don't really want to mess around with Python too much. He just want to do these tricks. But what he ends up with, that he starts to get this every other project, so he has to do it a lot, and I don't know, he has this carpal tunnel syndrome from clicking too much.
Yeah, okay, because just, I mean, that type of problem is probably widespread. I mean, I've seen it in, for instance, economy departments where they have Excel sheets they want to fit into systems, they manually do all these things.
Oh,
And,
really?
I
Okay.
mean, we're talking several thousand files, etc. But you know, it's probably if you solve that problem, you'll be could retire.
Yeah, okay. Good thing to check from. Thanks.
On this note, well, I'm not. I used to be in bioinformatics, which is similar, and now I'm just working as a programmer in a company. But on this topic, I have a colleague who likes to say, "Okay, be nice to me, or I will replace you with a very small script."
Well, it's
I think with all this manual clicking, this is
maybe it's a good idea to say, but when you are a PhD student, it's not really. You don't have that much weight in your words. But yeah, yes, that's a good point, of course. Usually, people who has this problem tend to find the master students that will do it for them. So.
Yeah, I can replace your master student with this.
That's too evil.
It's a joke.
But yeah, I get it. Hmm?
Actually, I noticed that a few times already in more or less related fields. There are quite a lot of researchers in different fields of applied mathematics and physics that can really write good algorithms that really solve their problems and actually can even do parallel programming and so on.
That's why
But
Fortran
they
exists.
completely fail in anything related, for example, file management or whatever else. So they basically do not really understand what is a file, how to deal with a file, how to like open it, do some other data and so on. So they're very good at dealing with like abstract data. So, okay, I need the matrix. Okay, there's some sort of a sparse array. That's fine. So they are pretty good with it. So to my point of view, that's a real mistake of the education. And I mostly dealt with it back then in Russia, but communicating with different master and PhD students here in Sweden, I see that it's quite a common case. So they really don't know how to deal with this like common thing is. Maybe it's just needed new libraries that will help them, maybe tweaking the education, maybe something else. So
Yeah, but I mean that's basically exactly this problem, that some of the concepts are way too over their head, so to say.
yeah, maybe I will ask.
They're not used to think that much of such a simple things as file for them.
Yeah, but
guess.
I understand that probably my wife knows what is a lambda function, but at least it will take me quite short to explain it to her. But I would guess that she will have much more problems with files. I would guess. Oh, okay, why should I upload to PNG? What is a PNG actually? I guess her probable questions.
Yeah. I don't really see how that can be solved either, but that actually in Sweden there is this fika tradition, which is a perfect case for explaining such things like what is a PNG file, which I find quite often the case in our scientific group, because that sort of discussion usually comes during that time.
The discussed issue with the people not knowing programming in general is a big topic in Sweden, and I mean, there's talks about giving lectures in programming already in middle school or lower grades. Would that be a solution to solve it for the actual work that they come to later?
I don't know. I know that in Russia, for example, there is this initiative of IT volunteers, which is a few platforms where you can submit your problem, and then you might have some luck, and some other person would find you and suggest that he can spend his time on it. I tried to Google for it if there's such thing in Sweden. I think I failed or at my Googling skills. Because there should be one, and maybe it's the case that this is too local.
Yeah.
So there might be some clubs inside universities, but I haven't seen such in my university at least.
Anyone else? Yeah.
So if you speed up the process of preparing these variations of input files with that are then sent to the black box, the supercomputers, and you gain several weeks worth of that job. Is there enough resources on the big computers to handle all these extra these new runs of data? Or will you get a new bottleneck, like all of a sudden the research community is so efficient in putting large,
Well, right now it's more like there are communities that figure it out, like the quantum chromodynamic stuff I've been talking about, and there are communities that I hope will figure it out eventually. So they're fighting for the same pie, but it's just distributed in different parts. What I understand from what I think will happen is that the more requests for resources there will be, the happier the guys from HPC community will be, because they will have reasons to build bigger supercomputers. Right now in Sweden there is some sort of a shortage, because a few supercomputers actually shut it down their resources to build a new, even bigger one. And because of the resource rerouting, we get a huge queue waiting time. But still, if you're the problem of preparing these files and submitting them is basically a context switching problem, which you want to keep as short as possible, because you want your time to solution to be as short as possible. And if you cannot shorten the simulation, then you should try to work out the other parts of it.
Hi, I have a question. You mentioned that you can, if you get one-liner solution, which can save 2 weeks of your time.
Well,
So-
it was
Oh, like okay,
mostly your estimation, but yeah.
doesn't matter numbers, but you gain free time basically by getting a solution. Would it be worse to study some programming languages? So you spend 2 weeks now, but you get one-liner solution, and then you can speed up your process.
Yeah, I can see like you can bargain with your friend, like I will show you this one-line solution, but you will have to read this book on Python instead. Or you can have like your 2 weeks, which this is a good idea. Thanks.
Thank you all, and thank you, Igor, for the wonderful session.
Thank you.